Good afternoon, everybody. You're all welcome to the webinar from Rocscience and Terracon, from modeling to real case studies using Settle3. Today is July 21st, 2021, and this is one of continuous webinars and training courses that are cast by Rocscience for explanation and training on our products. Rocscience is a world leader in developing two-dimensional and three-dimensional software for civil, mining, and geotechnical engineers. For over 20 years, we've built geotechnical tools used by more than 8,000 users around the world. We have over 60 employees at our head office in Toronto. More than half of them are holding advanced degrees in engineering. This is a picture of our head office, and it's an iconic building that usually tourists pass by and stop and take pictures for it. We're located in 54 St. Patrick Street, Toronto. We shall start our seminar. Our webinar is made of 4 parts. In fact, the first part will be presented by myself, Ahmed Mufty. I'm holding a PhD in geotechnical engineering and a professional engineering license from Ontario. I'm a geomechanics specialist in rock science. The next parts will be presented by Yipin Lu, a geotechnical software developer in rock science, Steve Kai, geotechnical software developer in rock science, and Dr. Deniz Karadeniz, who's a senior associate in Terracon Consultants Incorporated. The last part will be a case study with application of Settle3, and the second and the third parts will be modeling for interesting new features that Settle3 is introducing in the latest releases. Let's start with an overview and what does Settle3 do, in fact. Settle3 as a program is not a single task program. It does several tasks for the user. The major goal of the program is the calculation of settlement. So it passes us from settlement to consolidation and creep. It also applies ground improvement. You can make liquefaction analysis. You can apply multiple boreholes and soil layering. You can have expediters for drainage. It does Cpt analysis, which is very interesting. You can get a lot of information out of this. It integrates also with SAFE, S-A-F-E, which is a very popular software for designing and analyzing rafts under the structural loads. So also we have within Settle empirical methods you can apply. You can have different types of loading. You can have different choices for stress distribution. And one of the most important features that is the staged construction. You can load in stages and unload in stages. With time, and you can get the settlement through these stages. The settlement is divided into three parts: immediate settlement, primary compression, and secondary compression. The immediate settlement may be constrained in one-dimensional, or it takes the effect of three-dimensional distribution of the stress. The primary compression settlement, as we know, it is mainly calculated either linearly or non-linearly using the logarithmic, the semi-log relationship between the void ratio and the effective stresses. And we can extend that to a time-dependent consolidation calculations based on the usual Terzacki's theory. The secondary compression settlement, the third part, which is also called sometimes creep, that is based on the two standard method of Terzacki and Mesri method. The soils are defined either normally consolidated or over-consolidated. What I'm going through here in these slides, they are all built in and available within Settle. So we're talking about Settle3 features and Settle3 capabilities. So the soils can be normally consolidated or over-consolidated. The over-consolidated soils may be defined or determined by the over-consolidation ratio, the pre-consolidation stress, or an over-consolidation margin, which is the difference between the pre-consolidation stress and the effective overburden pressure. These three types may give you suitable or appropriate ways to define your over-consolidation. Note that all soil properties may vary with depth, and Settle3 allows you to change your properties through the depth. So anything you want to, for example, the modulus, for example, the over-consolidation ratio, the pre-consolidation stress, whatever the C sub C parameter or M sub V parameter, you can change with depth. So you have a depth dependent function you can apply, and you can apply a single value as an average value for a layer. Stress distribution is done in Settle3 in many ways. You can use the standard Boussinesq method, the Westergaard method. This is mostly appropriate for pavements and roads and loads like that. Multiple layers. So if you have a couple of layers and you have different parameters for the modulus, Poisson's ratio, whatever, if you want to distribute in the traditional vertical ratio 2:1 or any other angle, the stress computations in Settle3 may be one-dimensional and maybe three-dimensional based on the parameters of pore water pressure B and A. Also, it evaluates the mean stress, for calculation of settlement instead of the overburden pressure and the applied vertical stress only. The other feature that we need to pass through is a staged construction. So in Settle3, you can define your stages of loading, and each stage will be defined within the load. So which load at which stage, and you can time these stages as well if you have time-dependent calculations. One of the important features in Settle3 is ground improvement. Ground improvement may be, well, the three types of ground improvement in Settle3 are the soil replacement. You can replace a bulk block of soil with a new soil, or vibrocompaction. So you're vibrating the soil with vibro probes, or vibro replacement and stone columns. So you're replacing the soil with a better soil than the original one. And the vibro replacement or the stone columns may be without drainage effects or with drainage effects. The drainage effects may speed up the consolidation process. When defining the ground improvement, you need to define the zone. So you will choose the area that will be improved, the depth extent of that improvement, and the parameters for the soil improved soil. You can define the soils with multiple boreholes. You can use one borehole with horizontal layers, and you can use multiple boreholes with non-horizontal ground layers. You can expedite the drainage. Drainage expediters are defined also by zone. So you will choose the area that has the drainage expediter, the depth extent of that, then the parameters like coefficient of permeability, smear zone, etc. The drainage expediter types in Settle3, we have for the time being wick drains and stone columns. So the stone columns may have permeability, and they will add to the speed of the drainage, the same as wick drains also do. The loads applied in Settle3, the load types may be rigid, may be flexible. You may apply preloading. So there is a time for the preloading. You will remove the load at a specific stage. Then there are fill loads, embankments. You can apply excavation, horizontal loads also. The load shapes may be standard, circular, rectangular, polygons, conical, or even truncated conicals. The embankments may be layered embankments, so they are horizontal layer built in horizontal layers, or may be designed even with non-horizontal layers. These are, for example, types of the loads. We have circular, polygon. The polygon can take any shape. It's just a polygon, whatever the number of vertices are. Rectangular loads, excavation loads. We have truncated conical loads, fill loads. All these loads may be constant, so uniformly applied, or may be variable between the vertices. So you can apply a higher load at this side, a lower load on the other. This is a layered embankment. See how horizontally the layers are added. Or you can use the embankment designer if you don't have horizontal layers. For example, you had this embankment first, then you add the red part, then you add the green part. Also, we can import loads from SAFE, which is a finite element program that will give a huge number of loads and vertices for these, or nodes for these loads, and you can interact with SAFE backward and forth so that you can reach to the required spring moduluses for the foundation. So the structural engineer can use them in his structural analysis. Settle3 also gives 5 methods, or includes 5 methods for empirical methods in calculating settlement. So these are the Schmertmann method, Peck-Hansen and Thurber method, Schulz and Sheriff and D'Apollonia, and the last one is Berland and Burbage. You can go about all what I'm talking about in our website, rocscience.com, and you can see the theory manuals, a lot of help material, and many tutorials to teach you how to use these things. Another process that can be accomplished in Settle3 is liquefaction. So liquefaction analysis is dependent on soil properties fed to Settle3 as input, either a standard penetration test, SPT, cone penetration test, CPT, or the shear velocity, shear wave velocity. All these methods or all these properties will be accompanied by another dialog box which has choices for the method and for other parameters that you need to complete your analysis. I can't go through every single thing here because it's a huge amount of content. Please visit the website and see the theory manuals and the help material. In CPT analysis, you can get in Settle3 a lot of information. If you have CPT data, you can feed these CPT data to Settle3 and get the cone penetration resistance, the skin, the friction ratio, and out of this you may layer the soil. You get some type of layering for the soil. You can adjust that layering with some adjustment factors, and you can also get a lot of information out of this. These are the information that you can get from CPT analysis, from friction ratio, corrected cone resistance. There are a lot of things that you can get as soil properties from the CPT analysis. And you can use a couple of methods to layer the soil in different, you can separate the soil into different layers having different properties. The groundwater in Settle3 may be applied as piezometric line, maybe grid points defining grid on the plan. So at plan you have a grid X, Y, and at each XY you have a depth for the groundwater. And function also with depth, you can apply in Settle3 function for the pore water pressure with depth. These are all defining the initial or the hydrostatic pore water pressure. If you have excess pore water pressure due to loading, that will be manipulated and calculated within the consolidation analysis. With this, I'm done with my part. I would like to transfer now to Mr. Steve Kai to show you his part of the presentation related to ground improvement.
So, hi everyone, I'm Yipin Lu. I'm the software developer for Settle3. And today I'm going to introduce a new profile option provided in Settle3, the extruded section. And during this presentation, I will introduce the new feature and some backgrounds to it. And then I will show you all a demo to see how it works. So if you have any questions, please type them in the chat and we will answer them in the end. So in Settle3, it used to have two layer options available for users to create soil profiles. The first one, horizontal layers option, assumes all the layer boundaries are horizontal and the users only need to provide the thickness of each layer. Then the non-horizontal soil layers option will use multiple boreholes with given XY locations and local profiles to interpolate the soil profiles at any query locations. And now we just provided a third option in the latest release of Settle3, the extended section layers. This is a new soil profiling method we recently added to Settle3 that gives the flexibility to create a section with complicated soil layers. The goal of the new profiling method is to reduce the tedious and repetitive works to build modeling geology. Let's go take a look. So in order to make the new soil layer option work better with the traditional layering methods, we developed a new tool called Section Creator to provide an easy way to draw a section. In the Section Creator, as you can see in the screenshot, it allows users to create ground surfaces, which also called ground topography, and interior material boundaries. They can be created by using either the cursor clicks or using coordinate tables. And then using some predefined materials to fill the layers, it will become a formal section that represents the soil stratigraphy over the entire modeling region. This section profile will be applied at the location of a straight section line, which must be provided prior to this section creator. I will show you the entire process in the demo later. To further simplify the drawing process, we provide a Dxf Import function where users can simply import their constructed soil stratigraphy to the drawing space as a guide. And similarly, existing boreholes can be displayed in the section creator also as a guide for users to create their sections. However, the boreholes will not restrict the layout of the section and can be turned off at any time. They won't come into any further interpolation or calculations either. This is the main difference from this extruded layer option and the traditional non-horizontal layer option. So in this slide, the screenshot shows how the stratigraphy looks like after the extrusion of a 2D section. The left side is the predefined section line in the plan view. And then the yellow part over here is the 3D view, shows the extruded area. You can see from this screenshot that the material boundary along the soil box is actually the same as the material boundary along the section. And for any modeling region that is outside the defined length of the section, will always have the same profile as the section boundary profiles. So that's why the outer left and outer right areas have a flat material surface. There are a couple key points worth talking about in this new extruded section mode. Because we use a user-defined section to retrieve profiles for the entire engine calculation, boreholes are no longer used other than guiding users drawing their sections in the section creator. That being said, if you want to, you can even delete boreholes after defining a section without running into any issues. When the program runs any calculations at query point locations, our program will make a projection to the section line like this, and then find the profile at that projected location for this query location. So this profile over here will be passed into stress and settlement calculation. Then for existing borehole entities, they also make projections to the section line and display the borehole layerings in the section creator. But like I said previously, they will not be involved into any calculation. So after all, the stress and settlement calculation method remain unchanged, and only the way query profile is constructed has been changed. But I'd like to say, if you switch from borehole interpolation method to extruded section method, it is still possible to see some result changes in stresses or settlements. The reason here is because of the changes in local soil profiles. When all the profiles at query locations are directly obtained from the section without any coordinated interpolation, depending on the borehole setup, the changes in layer thickness, ground surface, and even some borehole elevation, the bottom elevation can give you a different result. If you compare these two screenshots, for example, at some locations of the borehole interpolated geometry to the left, such as the boundary of the modeling region over here, looks very different from the extruded section over here. And this will definitely affect the final results if a load and a query point are added at those locations. So this is totally depends on the engineering judgment and the project requirements to decide whether you should go with borehole interpolation or extruded section. And we suggest applying this layer option when the soil layering significantly varies in one direction, while in the other direction, it varies a little or even remain the same. All right, I will jump to a demo to show you guys how it works in Settle3. And I will close my PowerPoint. Can you guys see my Settle3 open over here?
Yeah, we can.
Okay, great. So this is a Settle3 model with a few soil materials defined. And we have 3 existing boreholes over here. So they are relatively in the same direction, but have different layer thickness in each of these boreholes. So let's go to the analysis and project settings. Go to soil profiles tab. And now it is the non-horizontal layer option. And we change it to extended section layers. Click OK. And then we go to soils. And you can see the section creator over here is enabled. Click that. The cursor then in the plan view will become a cross. This is because the first step to create a section is to define the section line. So we have to define a starting point and the end point for this line. And these perpendicular dashed lines are here to help you to visualize the potential extruded area. So once you define the section line, this section creator will pop up for you. So the layout of the dialogs is very simple. The horizontal axis in the viewport stands for the distance along the section line, while the vertical axis over here stands for the elevation. The dashed line over here means the area of the section line we just drew in the plan view, but this is just an indicator. It will not restrict actual length of the section, and the section can always be longer or shorter. So in this demo, let's just turn it off for now. And first, we'll define the bottom elevation of the entire section. So let's click Define Bottom Elevation. And we have 3 options over here. We can use the bottom of these boreholes, so it will always select the deepest borehole from all of these. Or we can use the ratio of the section length. Or we just use custom elevation. Let's give it a -75 here. Click OK. And then let's go to Draw Ground Surface. Click the button, and we can click along each of these boreholes from the one top to the another top, and connect them. Done. Then this is the basic layout of the section. Default material has been filled into this layer because we only have one layer for now. And we can assign materials to other things, but we will assign them later. Let's draw some internal boundary first. So go to internal boundary, and we can trace the layering of these boreholes. But the internal section always have to go through the entire section, which means it has to start from one side of the section and go all the way to the other side. But we are not restricting users to draw the internal points always following the borehole layers. For example, you can click the starting point at any point over here or at some other points in the middle like this. And you can even skip the middle borehole like this to make a boundary without using these boreholes. So that's what I mean in the slide. The boreholes will be a guide rather than any restrictions. So let's define another layer over here, for example. And next, let's assign materials. So the default material has been using existing fill for all these layers. Let's choose upper sand for this one, and lower sand for this layer, and deeper sand for this layer. All right, so this is the entire section. And once we click OK, you can see how it works in the 3D view. So these parallel lines shows how this section is extruded, because the parallel lines are always perpendicular to the section line displayed over here. And once we finish showing this, we can go into the next step of the modeling. So because this feature only adds a way of defining soil profiles, you can continue adding loads. For example, you can add some polygonal loads as 0 and give it a pressure. And you can add grid points. It will automatically calculate for you. And you can even add more options like embankments, and all our previous feature works perfectly with this new feature. So, all right, this is all about the new feature to the extended section mode, and I hope you enjoy it. If you have any questions, please type your questions in the chat, and we will answer them in the end of the webinar. And I will pass my screen to Steve.
Thank you, Yipin. And thank you, Mufty, for providing coverage for Settle3, and Yipin for covering the new feature for Section Creator. Today, I will be discussing the stone columns and drainage. So just a quick overview of what I'll be going over. I will be focusing on the stone column for ground improvement, and I will be introducing the drainage with drains first, just a brief intro of what we have and the comparison of what we have developed in stone column drainage option. So in terms of ground improvement, there are regions that users can apply by selecting soils, ground improvement, and add ground improvement region. And there are 3 different methods that users can use in this feature, which are soil replacement, fiber compaction, and stone columns. In soil replacement, it's a straightforward method where it allows users to define a region and replace the soil by another property that they can define in their dialog. Fiber compaction allows users to define the mean grain size, target relative density, and coefficient alpha for the replacement of the soil. And this is primarily used for granular material and is not effective for cohesive soil and some silty sands. In our presentation, we want to focus more on the stone columns, and it's a replacement of soil with pattern of compacted vertical stone columns. And as you can see in this diagram on the left, when you select stone columns, it allows users to define the top elevation, the bottom elevation, spacing, and the pattern, and along with the column properties of the diameter and elastic modulus of the stone columns. And you can also define different stages at which these reinforcements are applied. And on the right, you will see that you can define in different multiple regions on how these stone columns are applied under the load. Some additional tips for stone columns is that there is a threshold limit for interaction on stiffness of the column to the stiffness of the soil for ground improvement. So adding a stiffer stone column beyond this limit will not improve the settlement. And the elastic modulus ratio for this, the EC, elastic modulus of column, to the ES, the surrounding soil stiffness, should be limited to 20. And this is presented from the principle and practice of ground improvement by G.A. Han. And you will see in this equation where when they calculate the stress concentration ratio, they have this cap limit of the modulus ratio of EC over ES equaling to 20. The new feature for Settle3 with regards to stone column is the allowed drainage option. And stone columns can also be used to accelerate consolidation with drainage path. So we have allowed user to now introduce the 3 parameters, the ds over dc, which is a smear zone to drain wall parameter diameter, kr over ks, the undisturbed to smear soil permeability, and the permeability of the stone column itself. And you can define this in different stages. Just a comparison between the wick drains and the stone drainage is that if you look at the wick drains, there are dimensions such as drain, the smear zone, and the clay layer. And you'll also see that in stone columns, there are dimensions for the column itself and the smear zone and the drainage surface as well. The key notable differences between these 2 equations when calculating the degree of consolidation are the following: the f prime m and the mu factor. These 2 equations, I don't want to go too much in details, but they are similar, but they do have a very distinct difference, which later comes down to the calculation of the TR, which then actually incorporates the stress concentration ratio of the stone columns to the surrounding soil. So the drainage equation takes into account the stiffness ratio of the columns to the surrounding soil, whereas wick drains will simply consider its own input as the smear zone parameter as an input. So at the end, the required input parameters for stone column drainage would be the following, as I've mentioned before. The first one needs to have the ratio of the smear zone to the drain well. Second one being the K over Ks, which needs a ratio of the permeability of the undisturbed to the smear zone. And lastly, the vertical drainage permeability for the stone columns. Just to show the example of what happens when we introduce the drainage feature, on the left-hand side, you will see an example of consolidation after 1 month of applying a load. And you see in our time query points, to reach a 90% of consolidation, it takes approximately 17 years without the drainage. But with the introduction of drainage, with the same load, now we have improvement of reaching 90% of consolidation with approximately 9 years. Some of the future steps and any suggestions that you have for us, we are more than willing to always open to new ideas. So please send them to our technical support, and we'll be happy to look into it more in details. But the future addition with this feature that we have on our side is adding option for the half drainage length. As in the paper, they often introduce the drainage path to be half length versus the full length. So that is something that we have in mind. And also the ground improvement drainage to be applied to the sensitivity analysis. Currently, in our Settle3, we allow users to define different range of parameters for elastic modulus, spacing, the top depth, the bottom depth, etc. But we do want to incorporate these 3 parameters that we have defined for the drainage of the stone columns to be in sensitivity analysis. And as I've mentioned before, if you have any suggestions, please feel free to send us any feedback. And now I will move on to the demos. This is an example of multiple loads being applied in primary consolidation, so staged construction with the offices, so square loads, with the circular loads being the water tanks. And if we actually go to the analysis and project settings, you'll see that we have enabled the time-dependent consolidation analysis. And we have approximately 10 stages going from failing to constructing the load, and then consolidation and so forth. In this model, we have 8 boreholes in total. So if you go to the boreholes, let's actually go to list of boreholes, and you will see that each borehole has a different material layouts. the soil property layout of the boreholes, as you can see here. And in the model, we have created more complex model with the multiple boreholes using the section creator. So what Yipin has shown very nicely in his example, this is more of an extended version of what you can do with this feature. And now I'm going to show you how to apply the ground improvement using stone columns. So in this model, let's go to stage 2. So before we apply a load in stage 3, we want to apply a ground improvement in stage 2. So select stage 2 and go to soils, ground improvements, add ground improvement region. And we want to apply stone columns. And the top elevation to be 5 meters, bottom elevation to be -5. We'll keep the default setting of spacing square and column properties of diameter of 0.6 to elastic modulus of 80,000. And we want to apply it in stage 2. Select OK, and you will notice that for example purposes, I've left out 2 of the loads that are not applied with the ground improvement. So we will just apply along the edges of the loads. So just follow along like this, and you'll see that the stone column has been applied. And we'll do the same for the other one as well. Stone columns, 5, -5. Default values, stage 2, select OK, and then we'll just draw along the line of the load. And this is some question that some of the customers has been asking was, how do I apply a circular ground improvement? And you can also do that by selecting soils, ground improvements, stone columns, and now we'll apply a spacing of 0.8, triangular. Let's keep the top elevation, bottom elevation the same, and apply it at stage 2. Before you select any vertices, you'll see that the option, there are table, circle, and etc. So we'll just press I for circle. And we'll be using a center and point on the circle with number of segments being a default value of 40. Select OK. Select the center of the circle and select the edge of the load. And this will be one of the ways in which you can apply a circular shape ground improvements. And as I've mentioned before, you can also have a coordinates of the stone column regions, and you can enter it using tables. So triangular, OK, and we select middle. Oops. So this is one mistake I've made, is we have to make sure that we select, my apologies for the mistake. Okay, and we select I to go into the circle, select OK, center to the end. Okay, we will now compute, and you'll see that the consolidation analysis has been analyzed with the stone columns. And now this is where the meat of the presentation comes into play, because we were introducing the drainage feature. So now I'll show you a model that actually has the drainage features. This is an identical model from the previous example, you see from here. But what I've done is I went ahead and applied the drainage for all of the ground improvements. So you'll see that the top elevation, bottom elevation spacing modulus are identical to the previous model. But if you see here, each of the ground improvements now has allow drainage option on, and I will apply these values, the smear zone to permeability ratio to the permeability of the stone column being 11.5 meters per year, applied in stage 2. And I've applied it to all of the ground improvements. And this model has already been analyzed. And what you will see is that after 1 year of load and consolidation, you will notice that if you take a look at the quarry points, the primary consolidation has been significantly improved after 1 year. And what you will also notice is that the time to quarry points, the time it takes to reach 90% with the drainage has been improved to 100,000 days, as opposed to 120,000 days without the drainage. So you will see a significant difference improvements in the consolidation by using this feature. And if you want to find more about this feature, we have a documentation that's available discussing the theories and discussing how you can model this with this feature. So thank you so much for your time. And if you have any questions, feel free to type in the chat, and also you can send us an email. And so now I'll be passing over my presentation to Deniz.
Good afternoon, everybody. My name is Deniz Karadeniz. I'm with Terracon. And for those of you who are not familiar with Terracon, I would like to start my presentation quickly to give an overview about Terracon. Currently, we have 150 offices in all 50 states of the United States. In Virginia alone, I believe we have about 7 offices, and we continue to grow. According to the Engineering News Record, that's ENR, that's what stands for, is we are ranked #1 for asbestos and lead abatement, and number 24 for the top 500 design firms. We have wide range of services as outlined here, from environmental, facilities, geotechnical, and materials. I am in the geotechnical department, and of course I know more about these services. We do, for example, our own drilling. We have the soil drilling machines. We do our borings, the institute testing. We can do geophysical testing, our own laboratory testing. We do the planning, the design, the installation of the geotechnical instrumentations. We do construction monitoring and support. And in Virginia specifically, we can actually do, we have the karst expertise. We can do rock mapping and rock engineering, and the photogrammetry using the drones. For example, the picture that you're seeing on the left is just showing some of the fractures and discontinuities that we mapped. And these are really not accessible locations with just one person. So it makes it a lot easier just to do the drone survey. We can do our payment evaluation, deep foundation testing, instrumentation, and further the geostructure and support of excavation design. So we have a whole bunch of service lines that we can do. The project that I work on generally are transportation related. Specifically the design build projects, because they are fast track projects. I have completed other commercial type projects as well, but in terms of the complexity and the need for determining the most cost efficient designs as quickly as possible, the design builds are a different animal. But the benefit is that you have the control over the risks for the assumptions that you're making, and of course the quality control after that. The case history that I'll be talking about here is for I-64 widening. This I-64, the Interstate 64, is located between Richmond and Newport News or Virginia Beach area. The project construction already finished. It's done deal. It's finished in 2019. Our goal here was basically to build a new widening. So the existing one was located on this side, and we ended up adding additional lanes on both sides of the westbound, which is this side, and the eastbound on this side. Let's see. As you can see from this cross section, the initial plans for this bridge was to have the abutments on the top of this this embankment. The plans have been updated, so it was updated such that the contractor wanted to build an MSC wall instead, and that means actually there's a lot of addition of the new fill, right? The piers are gonna go, there will be less span. It is actually cheaper for the contractor, but actually that comes with some additional issues, because the geology that we're dealing with here was the coastal plain deposits. The coastal plains are mainly soft, sandier, marshy clay deposits. So we needed to do some extensive analysis on this one. And I will show you some additional details on some of the complexities on this. Just to give you a plan view, these are the plans that the structural engineers generally prepare. It looks complicated, but it's not that bad. You can actually see from the already constructed plan that the side of this actually corresponds to this side. So this is the abutment B, and you can see the existing abutment that they're showing on the westbound and the existing abutment on the eastbound. And these are the limits of the face of our MSC wall. Further into that, and I was actually showing this AA line here, and in the next one you'll actually see. So this is the Settle3 model that is constructed based on the topography. That is the face of the MSC wall, and this area is basically the reinforcing area, the reinforcement area. And we needed to have some wick drains to help with the post-construction settlements, and that's what we're showing on the wick drains. This AA section that you're seeing on both sides is basically the same A section that you're seeing here. And you can see the differences because this entire embankment was basically existing fill, so it was built. Because of that, there was actually differences in clay properties, right? Because when there is no existing fill, no additional stress, then you will have basically normally consolidated clay. On the other side, you will actually a little bit of more consolidated clay, not like normal consolidated clay or consolidated clay in some sites. And there is a transition zone that was happening as well. So we try to basically model this such that we can capture this this distribution where it was actually sloping. So that's what you are actually seeing here. By modeling it from really like 50 years ago, we started with that, and that is the limits of this new field that you are actually seeing. So just to give you a very quick summary of the steps, the first thing you need to do is review and update the settings, and I'll be explaining more of this. Plan the stages on paper or a Word document, describe them clearly, definitely, because you don't want to get confused yourself. Select your coordinate system that will be most useful and user-friendly. For example, for the roadways, we always have stations. So having those stations on Settle3 is very helpful because we can easily pinpoint our locations. Or you can select, if you don't have the stations available, you can select an obvious stationary feature. For example, a face of the MSC wall, which is not going to move at all, but that will be your stationary face or station. You can mark that as 0, for example. Then next you determine the loads. You look into the new fill heights, how it varies with distances. If you have the retaining walls, for example, if you're doing again roadway, you need to have service base pressures, and then that's what you will be applying. And then of course you're going to need the subsurface information and the soil parameters. I talk about the project settings because if you don't actually start with this, your settings can be completely different, and you are basically doing your garbage in and garbage out. You need to understand the variability, right? Because all of these settings, the ones that I'll be showing next, is going to cause some kind of multiple effects, and then you will have different settlement estimations. And looking into the properties, I generally suggest people to basically plot that data based on depth, so you can actually see how it varies with depth, so that your properties actually you're getting a little closer to the accuracy. In this case, we have plotted ours based on the lithometer testing, pre-consolidation pressure, and then also the consolidation test results, so we could see how they were varying. And there is a good match in this case. The time-dependent consolidation analysis, you need to make sure you check this one if you are, especially when you are doing the consolidation testing, because if you don't do it from the beginning, it may actually cause some issues, and you just want to make sure that you start right from the beginning. Some of the advanced settings, as Ahmed explained in the beginning, you can use the vertical stress and the mean 3D stress. The significance of this is that vertical stress only is the one-dimensional stress, and that stress actually should be used with the concentrating modules from the dilatometer testing, for example. You need to use the mean 3D stress if you are using the Young's modulus, and because Young's modulus is 3-dimensional modulus. for consolidation testing, any of these stresses doesn't matter. The other important one is the settlement cutoff that you're seeing here. This makes a big difference for the large embankments, but it's not a big difference for it doesn't cause really big difference for the shallow footings. And this is, depending on, again, the risk that you're taking. I sometimes set up to 10% cutoff because with the bigger embankment, your stresses will be much deeper, and there's really no need to have those stresses going that deep. And all of these actually will help with your settlement calculations. So if you are not sure with any of these other parameters, keep them unchecked, because some of them may be affecting, some of them may not, but still, if you're not sure, keep them unchecked, and you'll be safer. The next thing is you need to, again, define your stages very clearly. And in this case, you just want to make sure that what stage that you're in, because you need to mark this in your set of input. You have the time begin, the time end, and the duration. And then you can describe, okay, in this stage, I'm going to install the wick drains. Okay, then I'm going to have my piles installed. Then I'm going to place my embankment fill, then my surcharge, and then I'm going to remove my surcharge. These are actually important steps to basically make sure that you point it out, and when you're discussing to the client or the manager, it's basically very helpful to have this, and everybody will be on the same page. This is especially important to actually also discuss with the contractor if you are working with them to get a reasonable estimate on these durations, the construction durations. The model building is pretty simple. For example, if you're doing the fills, you can actually use the embankment load or the polygonal load. I personally like to use the polygonal load because I have the freedom to do whatever geometry that I want. For example, in this case, I have a different geometry, and you can see that geometry here. And if you look into that, if I define this, I can actually define with different stresses. For example, at the bottom here, if you imagine this is kind of a cone shape now, 4, 5, 6, and 7, they have 0, and 1, 2, 3, they have a certain magnitude stress. This is basically, if I take a cross section from this here to here, it's telling me that I'm applying a sloping condition new fill. The other thing that you can actually do here is the advanced staging, and this is the load factor. So that means 0 means you're not applying any load, 0.5 means you're applying 50% of the load, and then new means you're applying 100% of the load. You just need to make sure that this is all continues to 1 for all your stages, because otherwise you can, like, if it is a surcharge, you can actually get rid of that by mistake. The wick drains, I'm not going to talk too much about that. There's an excellent manual from FHWA that actually gives great information on this. That's the ground modification method reference manual. And chapter 2 is the vertical drains and accelerated consolidation. It's an excellent manual. These parameters that I'm showing here is actually kind of the estimate from or recommendations from that manual that I use for the wick drains. The surcharging option is you again have the preloading option or the polygonal load. You can go either way. They are both the same, really. They give the same results. I sometimes use the polygonal load if it is like I have the different shape, but the results will be the same. Most important thing here, though, if you're applying that surcharge and then you're taking that out surcharge, you need to make sure that your unloading modules, for example, it's properly defined. Because what I have seen most people do most of the time they keep 350, for example, in this one, 350 put here and then 350 here. It will work if it is only compressional stresses, right? But if you're unloading it, that will actually cause some issues. So you need to make sure that you understand that. And generally speaking, if you read the references, it varies from 2 times to 4 times the modulus value. So you need to make your own estimates on that one. Otherwise, you will see the weird results. So in this case, we actually did the measured and the estimated. We have settlement plates that we installed, and then we had the piezometers that we installed at different depths. You can see here, this one is the one that was actually estimated, and these two are the measured values. And looking into this, actually they look pretty close. The settlements, they are different because there are so many variables, and we are using the average values. And usually working with other officials, they like to see, like, they want you to use basically more conservative values. But at the end of the day, our measured data is what is controlling. One of the lessons learned I could actually get from this is that, like, the staging construction, right here, the reason that I'm actually getting my estimated value is increasing suddenly is because I did not do stage construction here. If I had done that, I'm sure that stage construction would have actually go more similar to this one, more flatter curve, and that is the reason that we are seeing this sudden increase in settlements for the estimated values. But the most important comparison is I think looking into the measured versus estimated is like I can actually see, even for the estimated, I can see that my curve is kind of flattening here. And I can confidently say that once I have these 3 or 4 back-to-back same readings, then I can say, okay, my surcharge has done its job. Now I can take my surcharge out and have my full payment constructed. I included a couple photos. This photo, it actually shows the wick drains, how it's installed, and you can see it's a crappy material at the top, and they also need to place gravel at the top of this so that it kind of serves as a drainage layer. And you can actually see the corner. If you remember the corner that I showed you for this wall, this is kind of not completely constructed yet, but at least they constructed the MSU wall on this side. So that's all I have. Thank you. If you have any questions, let me know.
Thank you, Dr. Deniz. Since we are running low on time, I think we only have a few minutes to answer some of the questions. Dr. Deniz, this is a question for you from one of our attendees. What was the expected amount of settlement for this project?
Expected amount of settlement for
this project?
Oh, so it depends on the project. So what we are looking for, or what we were looking for, is Virginia Department of Transportation. And Virginia Department of Transportation, what they say is that once you have your fill constructed for the bridge approaches, you need to have not more than 1-inch post-construction settlements within the 20 years. So it's very specific. Beyond the 100 foot to the approach, our post-construction settlements were set as 2 inches.
And another question for you. Oh, sorry.
No, please go ahead.
Yes, another question for you, Dr. Deniz, is how did you decide there was a need to speed up consolidation? What criteria did you use?
Oh, the need for speeding up was basically the construction stages, because this is the construction that is given to us. So what is this telling us is basically, once I actually place my for example, layer starting at 2 months, I have only 6 months of construction time, right? 2 to 8 months. Well, this is telling me that I need to have my post-construction settlements completed within the first 6 months. If my post-construction settlement is not completed for the first 6 months, that means I have a problem. And in this case, I need to install the wick drains, because that was actually helping with the post-construction settlement. It was reducing it by, I think, 4 or 5 months. Otherwise, it was just going to exceed another 4 months. And as I mentioned, this particular project, it was, the existing, it had to be operational, so we have the still cars passing by, and we have limited time. So we have to construct one and then move on to the other, replace the bridge, and then complete the construction. So very limited of the time, basically what made us go for the big trains.
Thank you very much for your answers. We have run out of time, and we've tried our best to answer all of the questions that you have posted in our chat. But in case if you have any further questions, please feel free to send us any email through technical support, and we'll try our best to answer any of the questions that you have. We want to thank you so much for joining us, and please, send us any email, and have a great day.
Thank you.
Thank you.